Hi guys, this is Miss Adams, and we're going to be looking at the Unit 9 test review. So the goal of Unit 9 is to really learn how to factor quadratic functions to go between standard and intercept form. Purpose of doing that is so that we can find the key characteristics of our quadratic functions in the different forms, because I know that standard form yields the y-intercept, factored form yields our x-intercept, so this just gives us a way algebraically to find the different key characteristics. So let's just start off with this first page, and this first page really focuses on factoring in the different ways. Looking at this first grouping, it says just factor using the greatest common factor. So we're looking for something that all of the terms given to us have in common. So number 1 says 3x squared plus 15x. And we want to look to see what is the largest factor that can come out of both of these terms. So I know I'm going to divide both of these terms by some greatest common factor. Let's look numerically. If I'm looking at this, my smallest coefficient is 3. So I already know that 3 is a factor of 3. It's the greatest factor of 3. But then I'm going to look at the number 15 and see if it is divisible by 3. And it is. 15 divided by 3 is 5. So I know I can at least take a 3 from both of these terms. I also am going to look to see if they both contain the same variable. And the first term has an x squared while the second term has an x. So the largest variable that I can take from both of these is an x. So in order to factor this out, I'm using the reverse distributive property. So I'm factoring out that 3x, which leaves me with x plus 5. Because 3x squared divided by 3x yields just an x. 15x divided by 3x is 5. Looking at the next grouping, one of these things that your teacher may have touched on is the fact that we don't want our initial or our leading coefficient here to be negative. Our leading coefficient should be positive. So the first thing I look at when I look at this, I'm like, oh no, my leading coefficient has a negative, so I know I'm at least going to need to factor out some negative value. So I'm going to go ahead and write that in here. So from each of these terms, I'm going to take out some negative value. Next, I'm going to look for the lowest numerical coefficient from the 3 terms, and that is a 4. So I've got 4, and I know that 4 is a factor of 4 because it's the greatest common or the greatest factor of 4. 16 does also contain the factor 4, and 12 contains the factor of 4. So now I'm going to factor out a negative 4 from each of these terms. And the last thing I'm going to look for in all 3 terms, do they all contain a variable? And in this case, they don't. So negative 4 is going to be my greatest common factor. If I divide each term by negative 4, I'm left with negative 4y squared divided by negative 4 is y squared. Negative 16y divided by negative 4 is a positive 4. Sorry about that, guys. And 12 divided by negative 4, plus 4y, then minus 3 as my last term. Because 12 divided by negative 4 is negative 3. And if I'm looking at number 3, it says 25m squared plus 40. Now, I know I'm not going to take out a variable term because both of these terms do not contain variables. So the next thing I need to look for is my greatest common factor. If I look at my lowest coefficient, I've got the number 25. But 25 really is not a factor of 40. It's not a whole number factor. There's no other number multiplied by 25 that yields the number 40 that is a whole number. So if I'm going to the factors of 25, I've got 1 times 25 and 5 times 5. So let's look and see if 5 is a factor of both of these numbers. And it is, because 40 ends in a 0. So I know if it ends in a 0 or a 5 is a multiple of 5. So I'm going to divide 5 out of each of these 2 terms, which will leave me with 5m squared plus 8. 5m squared plus 8. Neither of those have a greatest common factor, or the greatest common factor between those 2 terms is 1. So that is as low as this factoring is going to go. All right, that gets us to our next section, which our next section is a mixture of trinomial factoring, difference of 2 squares, and factoring by grouping. So let's look at this first one. It says 2x squared minus 10x plus 12. I always need to look for a greatest common factor first. Looking at my lowest coefficient, I've got a 2, which means I can probably factor a 2 out of each of these terms because all 3 terms are even numbers. If I factor out the 2, I'm left with x squared minus 5x plus 6. So I know that my GCF is a 2. I'm going to save that for later. And now I need to make my chart. I got to list out my A, my B, and my C values. I got to find A times C. And then I got to figure out two numbers that multiply to A times C and add to B. With my A value now being 1, my B value is -5. And I have a C value of 6. So I need these numbers to multiply to a positive 6, but add to a -5. I know the factors of 6 are 1 times 6 and 2 times 3. But I need them to multiply to be positive, add to be negative, so both factors need to be negative. So comparing these, -1 plus -6 yields a -7. And -2 plus -3 is going to yield a -5. So this is the factor set I want. I'm going to break that -5x into -2x plus a -3x and bring down my positive 6 and my x squared. Then I'm going to factor by grouping. I'm going to group the first two terms, group the last two terms. Divide out an x for the first two terms because that is their greatest common factor. And I'm left with x minus 2. Then, if I look at the next grouping, I want it to have the same coefficient signs and the same signs as what's left inside the parentheses from the first grouping. I've got a -3x plus 6, but I want that leading coefficient to be positive, so I'm going to factor out a -3 from both of these terms. By doing so, that leaves me with x minus 2 inside my parentheses. Those are the same thing. So my factored version, I've got to bring down my original greatest common factor of 2, and that's multiplied by x minus 2, multiplied by x minus 3. It does not matter which order you write those factors. So that was trinomial factoring. But the next one's a little simpler because we've got x squared minus 3x, or minus 30, excuse me guys, x squared minus 36. Looking at that, this is a special case. It is a difference of two squares because I know x squared can be rewritten as x times x. And I know that -36 can be rewritten as 6 times -6. So I'm going to factor these together. I'm going to have an x plus 6 and an x minus 6. And that will be my factored form. I can check that by using the box method. Doing so, I'm going to be left with two middle terms of 6x minus 6x. And 6x minus 6x cancel each other out, leaving a middle term of 0x, which is what we have here for number 5. Let's go on to problem number 6. So I've already given you 4 terms, so we don't have to do the trinomial factoring fully because we've already got the 4 terms. So we're going to factor by grouping, but no matter what, we always start by removing a greatest common factor. So if I'm looking at 3x squared plus 6x plus 12x plus 24, I can already tell that there is a greatest common factor of 3. So I'm going to factor out a 3 from all of these terms. And I'm going to hold on to that GCF of 3 until the very end. So I'm going to have 3 multiplied by x squared plus 2x plus 4x plus 8. Now I can factor by grouping. So I'm going to group the first two terms, group the last two terms. From my first two terms, I've got the greatest common factor of x. So if I divide out an x, I'm left with x plus 2. My second two terms are 4x plus 8. 4 is a factor of both of these, so I'm going to divide out a 4. And I'm also left with x plus 2, which are the same things inside my parentheses. And therefore, my final factored version, I'm going to bring down my greatest common factor of 3. And I've got x plus 2 multiplied by x plus 4. Now let's go on to problem number 7. It says 4x squared minus 81. And this is also a difference of two squares. Guys, anytime you've got a two-term polynomial, so a binomial, and there's subtraction in between, and it's asking you to factor, the first thing you need to look for is, are these perfect squares. And if not, then look for a greatest common factor. Well, automatically, these are perfect squares. 4x squared, I know, can be written in its perfect square factors as 2x times 2x. And then 81 can be written as 9 times negative 9. So I can factor this as a difference of two squares as 2x plus 9 and 2x minus 9. Once again, it does not matter the order of those factors as long as they're both there. Number 8 is trinomial factoring. First thing we look for is a GCF. And in this case, my lowest coefficient is 1, so my GCF is just 1. Now we define our A, B, and C values and create our A times C and B t-chart. I have an A value of 1, a B value of negative 4, and a C value of negative 21. So I know I want to find two numbers that multiply to a negative 21 and add to a negative 4. The only factors of 21 that I know are 1 and 21 and 3 times 7. But guys, I want them to multiply to become negative and also add to be negative, which means my larger factor needs to be negative. So I'm going to do 1 times negative 21, 3 times negative 7. 1 plus a negative 21 would give us a negative 20, but 3 plus a negative 7 yields negative 4. So that is the factor pair I want to use here. I can now rewrite negative 4x as 3x minus 7x and bring down the x squared minus 21. We can now factor by grouping. So I'm going to group the first two terms and group the last two terms. In my first two terms, my greatest common factor is an x. So if I factor out x, I've got x plus 3. In the second grouping, they both are negative, so let's go ahead and factor out a negative 7. And I'm also left with x plus 3. Those are the same thing, so my factored version is x plus 3 multiplied by x minus 7. And the last one in this grouping is another factor by grouping. I've got 6x squared plus 9x minus 14x minus 21. Unfortunately, though, we do not have a greatest common factor within these four terms. So we're just going to go ahead and factor these by grouping. In my first group, I've got 6x squared plus 9x. Now, although 6 is not a factor of 9, the next lowest factor of 6 is 3, and 3 is a factor of both 6 and 9, so I know I can factor out a 3 and an x from each of these terms. If I factor out a 3x, I'm left with 2x plus 3. Then I've got negative 14x minus 21. While 14 isn't a factor of 21, 7 is a factor of both of these, and they're both negative, so let's go ahead and factor out a negative 7 from both terms. That also leaves me with 2x plus 3. So those are the same thing. And my factored version is 2x plus 3 multiplied by 3x minus 7. All right, guys, that's my first two sets of factoring. We're going to look at some multiple choice questions here in just a second after we do some factoring again. But we're going to pause and go transition to the next video.